Drawing an error bar in R statistics when there are three variables and two of these variables are factors, i.e. Categorical, they have groups in them, and the third variable is a continuous variable or a scale variable. Launch the RStudio, and in the RStudio the first step is to load the tidyverse, and if the tidyverse package is not installed, then install that through R. And to load the package type library, open a bracket and then type tidyverse and then hit enter. The package will be loaded in R. It's already installed, but now it is loaded. The next step is to load the data file into R, and the way to do that is to use the command which is read underscore either table or CSV. And I'm going to generate an object and call it wage, then use the assignment operator and then type the function read underscore table, and then between the two brackets insert quotation mark and then type the name of the file, which is to underscore way underscore ANOVA capital letter and then dot text. Hit enter. It did not work because I had not set the directory correctly. So the way to do that is to go into the and click onto the session here, then scroll down to set working directory and then choose working directory, and this is the directory where the file is stored. Click on open and the directory is now set that contain the file. So just copy the command here, Control C and then Control V, hit enter. File is loaded into R. To view the data, use the command view, open a bracket and then type the name of the object, which is wage, hit enter. In the top section as shown here, a table that have three variables in it. Two variables are categorical or factors. Jobs are categorical, have 4 levels in it: doctor, dentist, pharmacist and nurses. And the gender is also a categorical variable that have 2 levels in it, so it is dichotomous variable. It has male or female. And the third variable is the salary, which is the wage of earned by each individual annually in pounds. So here we have 2 variables that are categorical or 2 factors and a continuous or a scale variable, which is the salary. To check the number of cases or participant in this data, type dim, open a bracket and then the name of the object, which is wage. Here as shown there are 96 cases or participant and 3 variables. Let's clean this section here, and then to look at the structure of the data, type str, open a bracket and then type the name of the object, which is wage. And as shown here, the type for each variable is given. The jobs are characters, the gender is character, and the salary is a number. Before drawing the error bar for this data, the mean and the standard deviation and the standard error has to be calculated for the all factors or groups within these factors. and the way to do that is to use the function which is group pi and summarize using the pipe symbols. So we're going to generate a new object and call it wage. Type here, let's clear this section first. Type wage summary and then assignment operator, and we're going to use the data from the wage and then use the pipe symbol here and then group, use the group function, and in the group function type jobs, comma, gender. So we're going to produce a mean, standard deviation, standard error for the data grouped by the two factors or the two variables, the jobs and the gender. Then pipe that function into summarize to generate a summary for the data. And in the summarize bracket, insert the mean. First type the mean equal to mean, then open a bracket, and we're going to generate the mean for the salary using a capital letter salary, as it is capital letter word. And then also generate the standard deviation, SD equal SD, open a bracket, again salary, and then comma, we're going to generate comma after the bracket, generate the number of cases by typing n equal to length, then open a bracket and again salary, and then comma after the bracket, and then standard error equals standard deviation divided by the square root of n, and close the bracket, or it's already here. As we shown here from this command, the command will generate a new object, call it wage summary, using the data from the wage object. Once this is generated, it will pipe that into group by, and we're grouping the data by jobs and gender. Once this is done, it will be piped to generate a summary using the summarize command, and we are going to look for mean, standard deviation, length, and standard error for the data. And if we hit enter to view the output, just type wage summary and hit enter. As shown here, a table is generated 8 by 6 showing the groups for each job or occupation category: dentist, doctor, nurses and pharmacists, and also grouped by the second factor, which is the gender, female or male, and the mean, the standard deviation, the number of participants or cases, and the standard error for each group is given here. To draw the error bar, then use the ggplot function or command, which is already installed with the tidyverse library. So type in the command section here ggplot and hit enter, so to get a bracket, and then we're going to add a plus sign and then use the geom point for drawing the error bar by typing geom underscore and then points, select the points and get the bracket. Once the bracket is inserted here, then within that bracket we need to insert the data, the name of the data, which is given a wage, or the name of the object, which is a wage, and then what data to include in the y-axis and in the x-axis. In the y-axis, we'll place the salaries on the y-axis, and on the x-axis the jobs arranged or grouped by the gender. And to do that is within that bracket type data, which is equal to the wage, and then comma, and to assign the variables to the y-axis and x-axis, type AES, open a bracket. Then for the y, it will be equal to the salary, capital letter, then comma, and for the x-axis is the jobs, capital letter, and for the grouping, then type the word shape equal to, then gender. After the bracket, insert comma. After the comma, type position equal to, then again position, and use the position jitter dodge, and a new bracket is generated, and then type dodge dot width equal to 1, comma, and then jitter width equal to 0.1, and then comma, then jitter height equal to 0. Checking for spelling and mistakes, the dodge here we need to add the D, and for the jitter width it's 0.1, and if we hit enter, a graph or a plot is generated on the right hand section. If we click on zoom, the graph is zoomed as shown here in the plot. On the y-axis is the salary measured in pounds, and on the x-axis is the job category. To have dentist, doctor, nurses, and pharmacists. As shown, the doctors have the highest wage, then second to a dentist, and then pharmacist, and then finally nurses. And these occupation are arranged by gender, females and males. To add the error bar to this graph, close that graph, then we need to add the standard deviation, or mean plus or minus standard deviation or standard error. In the current case, I will add the mean plus or minus standard error. And the way to do that is to first copy the command and then place it here, paste, and then insert a plus sign, and again type GOM underscore point, and then a bracket are generated, and we'll insert here the data or the outcome of the wage summary we had just generated here. So the data will be equal to the wage summary, and then insert comma, and then AES for the y and x axis, and for the y axis, or let's say for the x axis, going to place the jobs, so x equal to jobs, and for the y axis there will be a minimum and max, so we'll type y min equal to mean minus SE, which is standard error, comma, then y max equal to mean plus SE, then comma, insert a comma, and then group by the gender. Then after the bracket, insert a comma and then type the width, which is equal to 0.4, comma, position equal to position Hodge, and inside that bracket type width equal to 1. So double check the command here. For the first section of the command, we'll draw the graph. The second section should put the error bar. In fact, here we used the wrong one, so we need to use geom underscore error and go for the error bar, because we need to add the error bar into the graph. And the way to do that is to use the output from the wage summary, which has the mean and the standard error. And so on the x-axis will be the jobs, on the y they will be the mean plus or mean minus SE, and grouped by gender. If we hit enter and then click on zoom, as shown here, the error bar is placed with the upper and the lower, or mean plus SE and mean minus SE. The next step is now to add the mean to that error bar. Close this graph, copy the full command here, Control C and then Control V, and then add a plus sign, so we need to add a new command. Again, going to use the geom or type geom, and then underscore, go for the error bar, and in that function or command type the data, which is the wage summary. Click enter to include that. Then for assigning the y-axis and the x-axis, open a bracket. For x-axis is going to be again jobs. For y-axis we need to insert the mean between the error bars, so y max equal mean and y min minimum equal mean, and then comma shape equal to the grouping, which is gender. After the bracket, insert comma and then type width equal to 0.3, comma size equal to 1, comma position equal to position dodge, and between the two bracket type width equal 1. Double check that there is no mistakes in the new command or function, and then hit enter, and new changes will appear on the graph. If we click on zoom, and as shown here in the window of the plot, the mean is inserted between the two error bar. To assign labels on the y-axis and x-axis, let's close this plot window for this plot and then clear this. Copy the full previous commands and paste them here at this section with the geom error bar for the minimum and maximums and for the mean. To label the x and y axis, insert the plus sign and then type scale and then underscore and y for y-axis, so scale y continuous, as this is the continuous scale on the graph, and give the y-axis a name. Let's say here type name equal to quotation marks, since it is a text. We'll call it wages earned per year or annually, and then insert a comma after that and then expand equal to, and let's give it a range of 0, 0 and then comma again, and for the limit type or limits type equal, and then again the range from 0 100,000. Double checking again and found that the maximum should be 100,000, and then hit enter. A graph will be generated by clicking on the zoom as shown here. The upper limit should be more than 100,000, so let's close this and then copy the command again, copy, and then paste it here, and let's increase it to 120,000 and hit enter, and then click on zoom again. That is more sensible, as the upper limit is 120,000. And as shown here, the y-axis label is inserted, which is wages earned per year. To do the same for the x-axis, close this window and then copy the command here, copy, and then insert it here, then add a plus sign, then type scale again, underscore x, and x is not a continuous, discrete, so scale x discrete, and in the bracket add the name equal to, and let's call it occupations. Now overall, looking at the graph, we had drawn the points, we added the error bars, we added the mean, and then we added the label for y axis, and then for x axis is given a label of occupation. If we hit enter and then zoom on the graph, as you can see here, occupation is inserted on the in the x axis, and the gender is shown for legend on the right side, and the y axis is labeled. Close this window, remove the background, again select the commands or the function or functions, copy and paste here, and then add a plus sign, then use the theme underscore and go for the classics to remove the background and hit enter as shown here. If we zoom, the graph is finally shown with no background, with y-axis, x-axis and error bar shown. an error bar for each group and subgroup for all the two factors, for the female, for the gender, and for the jobs. So this is the way to draw error bar in R statistics for data that have 3 variables, and 2 of those variables are categorials, and they have, some of these variables have multi-levels in them, and a third variable that is continuous or scale.